Hi, Assalamualaikum and very good day everybody. My name is Faizatul Najihah Binti Razak, metric number 256766. Today, I would like to show you how to solve the application of partial derivative for the volume of coin. Okay, this is figure 1, the coin. The coin has height and radius. And the formula of volume is 1 over 3 pi r squared h, and the value of radius is 2 and the value of h is 5. So now we have to calculate the volume. We put the radius and height value into the formula. Now we 1 over 3 pi 2 squared 5 times 5. So the answer is 20.94. Now we have to change the radius with at 0.1 into radius. So the answer is 2.1 and h is the same, is 5. So we have to put the value of the new radius and the height into the formula. V 1 over 3 pi 2.1 square times 5. So we have to calculate, and the answer is 23.09, which means it's different 2.15 the value of volume from the old value and the value after we change the radius. Now we have to change the value of h with v at 0.1 from the old value. H 5.1 and radius equal to 2, and we have to put the value of the volume to the volume. 1 over 3 2 squared times 5.1, and the answer is 21.36. It's mean different 0.42 from the value of the old value of volume, 20.94. After that, we have to calculate the partial derivative. So we have to respect the radius first. The partial derivative, we have to respect to radius. Okay, dr over dv equal d, and the formula of volume 1 over 3 pi r squared h divided by dr. So we have to constant for 1 over 3 pi and h, and we have to differentiate for r squared, and the answer is 1 over 3 pi 2rh, and it's mean 2 over 3 pi rh. And we have to put the value of r equal to 2 and h equal to 5 to the new formula of volume. Okay, v 2 over 3 pi 2 5, and we have to calculate it, and we get answer 20.94. If difference of radius is 0.1, so the difference of value of volume is 2.09. Now we have to respect to h. Okay, dv over dh equal to the formula of volume pi r squared h over dh. Now we have to differentiate of h, and we have to constant the value of 1 over 3 pi r squared, and the answer is 1 over 3 pi r squared. So now we have to put the value of r and h, 2 and 5 into the the new formula of volume after we partial derivative. So volume 2 5 1 over 3 pi r 2 squared, and the answer is 4.19. If difference of h is 0.1 and the difference of volume is 0.42. We have to respect to radius. Okay, dr over dv equal d, and the formula of volume 1 over 3 pi r squared h divided by dr. So we have to constant for 1 over 3 pi and h, and we have to differentiate for r squared, and the answer is 1 over 3 pi 2rh, and it's mean 2 over 3 pi rh. And we have to put the value of r equal to 2 and h equal to 5 to the new formula of volume. Okay, v 2 5 2 over 3 pi 2 5, and we have to calculate it, and we get answer 20.94. If difference of radius is 0.1, so the difference of value of volume is 2.09. Now we have to respect to h. Okay, dv over dh equal to the formula of volume pi r squared h over dh. Now we have to differentiate of h, and we have to constant the value of 1 over 3 pi r squared, and the answer is 1 over 3 pi r squared. So now we have to put the value of r and h, 2 and 5 into the the new formula of volume after we partial derivative. So volume 2 5 1 over 3 pi r 2 squared, and the answer is 4.19. If difference of h is 0.1 and the difference of volume is 0.42.
Assalamualaikum. My name is Fildzah Irfan and Zaharuddin. My metric number is 256779. Today, I want to share you about application of multiple integral about volume. Bismillahirrahmanirrahim. I want to explain about application of multiple integral. This is the question. Double integral and volume explained. Let V be bounded above by the plane 3 equal 5 F2 and below 3 equal x square plus y square over 8 F1. Find the enclosed by the cylinder x square plus y square equal to 4 square. Alright. So you must put this with the formula. The formula is formula about volume integral that f2 xy minus f1 xy equal to dA. Okay. Integral d this f2 5 equal to x square plus y square equal to 8 dA. 0 to pi 0 4. Why you to get this is this formula? 4 you get for this. 5 minus r square cos 2 plus r square sin 2 is pi r minus 1 over 8 3 dr d lambda 0 to pi d lambda equals 0 4 pi r minus r equal to 8 dr. You must to solve this question. Pi r square equal to 2 minus r4 equal to 32. You can get r equal to 4, r equal to 0. So you can get 64 pi u3. That's all about application of integral.
My name is Firdiyana Binti Rosli. My metric number 2566768. Today, I would like to discuss about application of first order differential equation. I want to focus to exponential growth. Okay. The objective is the model exponential growth, and the second to solve exponential growth problem. We can use both formula to solve the exponential growth problem. Okay, this model exponential growth, which means the rate of growth is proportional to the population or amount. This can also be used to model continuous interest. We will solve this differential equation to find Pt, but the only function that satisfies this is Pt equal P E Okay, this is for remind you for exponential growth. Let's start by looking at an example. Okay, the question is a population of a small town grows proportion to its current population. The initial population is 5,000 and grows 4% per year. This can be modeled by dp over dt equal 0.04 times p and p0 equal 5,000. The question is find an equation to model the population. Determine the population after 3 years and determine how long it will take the population to double. This is question for find an equation to model the population. Okay, first we just write dp equal 0.04 p dt. Next we move a p beside this part. Then we integrate the n. This is the answer. Okay, for question number 1. The next question is determine the population after 3 years. Okay, as we know, I didn't told you before this. T, which is mean time or years. Okay, then this question one, the years, right? Okay, the years after the population after 3 years. Sorry. So we replace t for 3, and this is the answer. We just need to use a calculator to solve this. Okay, and this is last answer for B. Okay, that's all. So let's continue for question C. The next question is determine how long it will take the population to double. So again, starting with our population function, the initial population is 5,000. 5,000 times 2 is 10,000. So we're going to set a P of a T equation to 10,000. Divide both sides by 5,000. This would be 10,000 divided by 5,000. Then try and find the double time. And solve t, the proportion of logarithm, we take the natural log of both sides of the equation. So on the left side we have a natural log to equal. Here we can apply the power property of a logarithm. We can take this exponent here and move it to the front. So we have a 0.03 times natural log, but natural log e is equal to 1, so that simplifies out. So now we just divide by 0.04. And go to the okay, so we have a natural log to divide by 0.04. which happen to be our growth rate. So the double time is approximately, let's say, 70.3 years. I will it's for doubling time. Let's call it capital T. To natural log to divide by
Assalamualaikum warahmatullahi wabarakatuh. My name is Izzatul Shahirah Binti Baharudin, metric number 254503. Today I would like to explain about how to solve the application of second order differential equation for the homogeneous and non-homogeneous linear equation. Okay, today I would like to explain about the application of the homogeneous second order linear differential equation. This is equation ay second prime plus by prime plus cy equal to 0. So to solve that, we use the quadratic function, convert this one to this one, which is ar squared plus br plus c equal to 0. For homogeneous second order linear differential equation, gx is always going to 0. Okay. This is first example. How to solve this one? First one, we convert this one to quadratic function, which is this one, r squared plus r plus minus 6 equal to 0. So we from this equation we get the answer. This is r plus 3 r minus 2 equal to 0. So r1 equal to negative 3, r2 equal to 2. Okay, to solve that one, give the new equation, which is y equal to C1 e the power of negative 3 plus C2 the e the power of 2x, this one x. Okay, this is a new equation that we find it. Okay, this is for marginal equation. For the non-marginal equation, this is example 2. The same way to solve it by using the quadratic equation, which is this one, r squared minus xr plus 16 equal to 0. So this for this equation we get the answer is r minus 4 and r minus 4. So for this case, r equal to 4. To write the new function is like this, C1 e the power of 4x plus C2x e the power of 4x. This is a new function that we get.